Hello, welcome back to our discussion. Now the discussion is from section B. Okay, so what about the first question? The first question, that is assuming in section B, the first question, assuming complete ionization, same moles of which of the following compounds will require least amount of acidified KMnO4. So simply we have to assume the complete ionization, and we are given that FeC2O4, ferrous oxalate, then FeNO2 twice, ferrous nitrate, then FeSO4 and FeSO3. So assume that complete ionization, same moles of which of the following will require least amount of acidified KMnO4. Least amount of acidified KMnO4. Ready? Listen here. We know that acidified KMnO4 will turns to Mn2 plus, right? Yes. So the change in or the n factor in this case is 5. Agreed? Yes. And if the reaction is with the ferric oxalate, let the reaction is with the ferrous oxalate. I'm sorry, ferrous oxalate. This is ferrous oxalate with your KMnO4. What happens? KMnO4 having the n factor 5, right? Yes. What about FeS? It turns to Mn2 plus. Agreed? What about this one? This one, from your ferrous oxalate, there are 2 chances for oxidation, because there is a chance for the oxidation of iron because it is in +2, and there is a chance for the oxidation of carbon which is in +3. So the expected products are iron may oxidize to +3 and carbon may oxidize to carbon dioxide +4, right? Yes. So the total n factor, here we have 2 carbon, so 2 here. The total n factor here is, the change is 1 for the change in iron and 1 into 1, because +2 to +3, 1. So number of iron is 1. And moreover 1 for the change in carbon. So +3 to +4, 1 into number of carbon 2. So the n factor is 3, right? Yes. N factor is 3. Ready? And we know that the coefficient, you have to know that coefficient of oxidizing agent will be the n factor of reducing agent. Coefficient of oxidizing agent will be the n factor of reducing agent, and coefficient of reducing agent will be the n factor of oxidizing agent. Is it okay? Is that idea is okay? That means we know that for balancing this one, we have to multiply 5 here and 3 here. So 5 here, 3 here. Actually, this 5, the coefficient of reducing end, this is the reducing end and this is oxidizing end. Agreed? Yeah. This 5 is actually the n factor of that oxidizing agent. So the coefficient of reducing agent will be the n factor of oxidizing agent. Like this 3 is the n factor of your reducing agent. So the coefficient of oxidizing agent will be the n factor of reducing agent. And we know that in all these cases, the oxidizing agent is your KMnO4, whose n factor is 5. Okay. If we get the coefficient, we can simply compare it, right? So what about the case here? 3 mole KMnO. What is the question actually? The question is, which of the following require least amount of KMnO4? Least amount of KMnO4. Okay. Ready. So it is clear that 5 mole ferrous oxalate require 3 mole KMnO4. Okay, 3 mole KMnO4. Ready. Now, the same moles of following compounds. So these all are in same mole. They all are in 1 mole, right? So 5 mole require 3 mole. So 1 mole require 3 by 5 mole. So that is the first case. What about the second case? Is it required to balance the second case also in this pattern? Is that is needed? No. No need of writing the second one like this. We got the idea that the coefficient of something will be the n factor of opposite thing, right? So what about the case here? Here, the reducing agent. This is a reducing agent. Agreed? So let me find the n factor of reducing agent. That will be the what? That will be the number of moles of coefficient of KMnO4, right? Yes. So let me find the n factor. For that, your +2 iron may turns to +3, Fe3 plus. And your +3 nitrogen may oxidize to +5 nitrogen. Ready? So we have two nitrogen, so 2. So what is the n factor actually? For iron, that is 1 into 1. For nitrogen, from +3 to +2, the change is 2 into number of nitrogen 2. So the n factor actually I think 6. So n factor of reducing agent is 6. We know that the n factor of oxidizing agent KMnO4 is always 5. So what about the B case? This 6 is the coefficient of MnO4 and that 5 is the coefficient of what? Ferrous nitrate. So it is clear that 5 mole of ferrous nitrate require 6 mole KMnO. 6 mole KMnO. Therefore, 1 mole require 6 by 5. Like that, your ferrous oxalate ferrous sulfate. Ferrous sulfate. In ferrous sulfate, the Fe2 plus is in the lowest oxidation state. So it only oxidizes, not SO4 minus, because in sulfate the sulfur is in +6. It is already in the higher oxidation state. So it will not oxidize. So only Fe2 plus may oxidize. So it turns to Fe3 plus. So the n factor here is simply 1. Which means that 5 mole ferrous sulfate require 1 mole KMnO4. So this may be the answer. Let's check the fourth case also. Ferrous sulfite is the case. So here we have iron in +2, sulfur in +3. So it may oxidize to Fe3 plus. Iron may oxidize to Fe3 plus and SO3 may oxidize to Fe4 plus. Sorry, 6. So what will be the change? Here is +4, okay? So what will be the n factor? 1 into 1 plus 4 to 2, 2. 2 into only the 1 sulfur is there. So that of 4. 3. Okay. So the D choice, that is, this is the n factor of ferrous sulfite. So clear that 3 more ferrous sulfite require, it's not 3 more, 5 more ferrous sulfite require 3 mole KMnO4. So which will need least amount of KMnO4? That is your FeSO4. It's a good question, a lengthy question, a lengthy one for explanation. So it is clear that your MnO4 minus is an oxidizing agent, right? So if the number of moles of MnO4 minus increases means it have to do more and more work. More and more work means it have to oxidize more and more components. So in Fe2SO4, Fe2C2, FeC2O4, it have to oxidize Fe and C2O4. Here also FeNO2. Here also FeSO3. But here only MnO4 want to, or MnO4 is to oxidize Fe2 plus. So less amount of work will be here. So therefore, less amount of KMnO4 required is here. If you know that concept, then there is no need of comparing this all. Okay. So moving to the next question. So this is somewhat a good question, I think. So you got one more idea, that is coefficients and n factor relation. Okay. Coefficient of a substance will be the n factor of the counter or the complementary substance or the corresponding substance. Is it okay? Ready. Moving to the next question. The next question, that is, which of the following does not involve oxidation of iron? Oxidation of iron. In which of the following does not involve oxidation of iron? The first one is liberation of hydrogen from steam by iron at a high temperature. So when iron is treated with the steam at high temperature, what we call as Lane's process, we obtain Fe3O4 plus 4H2. This is the liberation of hydrogen from steam with the iron. Okay. So what is the case here? Here is iron well undergoes oxidation because 0 to a positive oxidation state. You know, this is actually plus 8/3 paradox oxidation state. So anyway, iron is oxidized in the first case. What about the second case? The second case is rusting of iron sheets. In electrochemistry, we will discuss the mechanism of rusting. Rust is also formed by the formation of galvanic cell on iron. Okay, where iron acts as anode and iron easily undergoes oxidation. So, iron will oxidize in rusting. Okay. Next is decolorization of copper sulfate by iron. If you are adding a copper sulfate with the iron have a greater tendency, or iron can displace copper. So it may turns to FeSO4 plus Cu. So it is clear that iron is oxidized. What about the next one? The formation of iron pentacarbonyl. Iron plus 5CO forms FeCO 5 times. And I'm already told you that in metal carbonyls, the oxidation state of metal is 0. So there is no change in oxidation state of metal when it forms a carbonyl. Okay, so it is not a redox reaction where iron is not oxidized. So the choice is, we can choose it as fourth. Okay. The next question, the role of hydrogen peroxide in the above reaction. There are two reactions. In question number 3, there are two reactions. What are they? H2O2 plus O3 gives H2O plus 2O2. Ready? And the next reaction, that is H2O2 plus Ag2O gives 2Ag plus H2O plus O2. So, here they ask the role of hydrogen peroxide in both reactions. Ready? So, what about the first reaction? In the first reaction, what happens? The ozone, which turns to oxygen, right? The ozone which turns to oxygen. So, oxygen is removed from ozone, right? Removal of oxygen. Oxygen is removed. If oxygen is removed, then ozone undergoes reduction. So, this will be a reducing agent. H2O2 will be a reducing agent. Okay. What about the second case? From +1 to 0. Silver is reduced from +1 to 0. So silver undergoes reduction. So H2O2 is a reducing agent. Okay. So in both cases, H2O2 is a reducing agent. Let's check the next question. Which are the following compounds nitrogen exhibit higher oxidation state? Okay, so the question number 4. First one is hydrozoic acid. What it is? Hydrozoic acid, HN3 or N3H. We know that in hydrozoic acid, hydrogen is in +1 and nitrogen -1, which means one nitrogen will be in -1/3. So we want to find the highest oxidation state of nitrogen in the given choice. Okay. So the next choice, that is next question, that is NH2OH, that is hydroxylamine. We know that OH having -1 charge and 2 hydrogen will be +2. So the net charge will be balanced by hydrogen. So +2 -1. +1 will be the excess. So nitrogen should offer -1. Move to the third one. That is N2H4. N2H4. We know that 4 hydrogen may offer +4. So these 2 hydrogen should offer -4. So our nitrogen, these 2 nitrogen should offer -4. So our nitrogen is required -2. One nitrogen is to have to supply -2. Okay. The next, that is NH3. Fine. NH3. We know that ammonia. 3 nitrogen may offer +3. So this nitrogen should offer -3. So this is in -3. So -3, -2, -1, -1/2. Okay. Ready? So which one is highest number? Highest oxidation state in mathematical sense, this will be the highest one, right? Agreed. One with the less negative magnitude will be the most positive one or highest one. So moving to the next, that is, the next question is from your electrochemistry. We can discuss it after electrochemistry. Okay. Question number 6. Check the question number 6. Question number 6 is the oxidation states of phosphorus in H4, P2O5, H4, P2O6, H4, P2O7 in the respective order. Okay. Fine. Listen. So these all should offer +4 and this one will be -10 because 5 into -2. So the excess charge is what? +6. -6, that should be balanced by your phosphorus. So 2 phosphorus have to offer +6, which means a phosphorus will be +3. Like that. Here will be -12. Here will be +4. So this should offer +8, right? Yeah. So 2 phosphorus is in +8 and each phosphorus should be +4. And here we have -14. Here we have +4. So this should be +10. So 2 phosphorus +10 means a phosphorus is in +5. A phosphorus is in +5. So the respective order is +3, +4, +5. Okay. So you can choose the choice as 1. Your choice as 1. Ready? So move to the next question. Moving to the next question. That is the oxidation number of phosphorus in PO4 3- and sulfur in SO4 3-. So PO4 3-, SO4 3-, sorry, 2-. So we know that this should offer -8. So for getting -3 outside, the phosphorus should be +5, right? So phosphorus is +5. Agreed? If the phosphorus is +5, then the -8 from oxygen will make a -3 charge outside. That is a simple logic. Here also a -8 from the side of oxygen. In order to get -2 outside, oxygen, sulfur should offer +6. So sulfur is in +6 oxidation state. Okay. So the choice is plus, and one more is the chromium in Cr2O7 2-. One more is the, so 7 oxygen will offer -14. In order to get -2 outside, this chromium part should offer +2. But it is offered by 2 chromium, means a chromium should offer +6. So it is +5, +6, +6. You can choose the choice as 4. Okay. Moving to the next question. Listen. Next question. that is the number of moles of KMnO4 that will needed to react with 1 mole of sulfate ion in acidic solution. Number of mole of KMnO4 that will need to react with 1 mole of sulfate ion in acidic solution. So that is the question number 8. So here your MnO4 minus is reacting with the sulfite. You know that sulfite is SO3 2 minus. Okay, in acidic solution means it is clear that your MnO4 minus may turns to Mn2 plus and having an N factor of 5. Agreed? Yeah, and your SO3 2 minus may turns to SO4 2 minus. What about the N factor? Plus 4 plus 6. The N factor is 2. So this N factor will be here and this N factor will be here. So clear that 2 more MnO4 minus require. What you are asked? How many moles of MnO4 minus for 1 mole of sulfite ion? Require 5 mole sulfite. So 1 mole sulfite required, 2 by 5 mole MnO4 minus. So there is a choice. The choice 4. Okay. The next question and next question all are from your electrochemistry or something related with electrode potential. Okay. We can discuss it in electrochemistry or electrochemicals related with the electrochemicals. So moving to the next question from your purely from your redox reaction. That is the 12th one. The 12th question, that is 2H2O2 turns to, we know that it turns to H2O plus O2. Fine. 2H2O plus O2. And we know that from -1 the oxygen turns to -2 and 0. Okay. So oxygen is oxidized as well as reduced. We know that this is a disproportionation. So oxygen both oxidized and reduced. Choice 4. This is the question number 12. Question number 13. What about the question number 13? Question number 13, that is which change requires oxidizing agent? For which change we require oxidizing agent? That is the question, I think. Yeah. So 2S2O3 2 minus gives S4O6 2 minus. Okay. A. So for a change where oxidizing agent is required means that change should be oxidation. The process should be oxidation. Then only the requires an oxidizing agent. Agreed? Yeah. So whether this process an oxidation or reduction from +2 to +2.5. So yeah, this process an oxidation. So we require an oxidizing agent. Question question is asked like that. Okay. Which change require an oxidizing agent? So the first one is okay, perfect. Because this process oxidation, so it requires oxidizing agent. What about the second one? The conversion of Zn to plus to Zn. So this process reduction, so here require a reducing agent because reduction will take place in presence of a reducing agent. The next is ClO minus become Cl minus. What about the change? From +1 here to -1. So this is also a reduction, required a reducing agent. What about the D? SO3. SO3 to SO4 to minus. So this is not actually an oxidation or reduction because SO3 have +6 and SO4 to minus also have +6. So the first one, thiosulfate to tetrathionyl from +2 to +2.5. So this is an oxidation process which require an oxidizing agent. So we can choose the choice as 1. Okay. The next question, that is something related with your displacement reaction. Okay, we can discuss it here. That is, given the following reaction A, B, C and D. Okay. This question require a detailed explanation. Listen here. Okay. Just read the question. The question is, given the following reaction A, B, C, D. Given the following reaction A, B, C, D. Okay. Involving A, B, C, D. Arrange A, B, C, D in the decreasing ability as reducing agent. In the decreasing ability as reducing agent. So, we want to arrange decreasing order of reducing power. Reducing ability means we want to write the decreasing order of reducing power. Reducing power means, what do you mean by reducing power? Tendency of losing electron, tendency of oxidation. So we want to write the decreasing order of tendency of oxidation, which means which one may lose electron fastly or easily. That is the first, then the decreasing order. Okay. So from that given data, we want to analyze which one lost electron easily. So the data are C plus B plus gives C plus plus B, first one. The second data, that is A plus plus D, no reaction. No reaction. Oh. The third one, that is C plus plus A, no reaction. Oh. Fourth one, that is D plus plus B plus gives D plus plus B. Wow. I think you're familiar with this idea. Listen here. Zn, listen here. I'll give you an example. CuSO4 plus Zn gives, tell me, ZnSO4 plus Cu. Why? Why it is so? Why the zinc displaces copper? Or this can be written like this also. Cu2 plus plus Zn gives Zn2 plus plus Cu also. We can write it in this manner also. We can simply ignore the spectator ion, SO4 2 minus. Spectator ion. What it is? Spectator ion. So, if this reaction takes place means zinc have more electron losing tendency than Cu, right? Zinc have more electron losing tendency than Cu. This means that if this reduction takes place means that zinc have more electron losing tendency than copper. Okay? Or zinc good reducing agent than copper. Zinc is a good reducing agent than copper. Means zinc have greater tendency for oxidation than copper. Fine. Ready. Or if I have, listen here, Mg2 plus here, along with the Zn, there is no reaction. What it indicates? Zinc is not able to reduce magnesium, which means that zinc have less electron losing tendency than magnesium. Means magnesium is a good reducing agent. Good reducing agent than zinc. Is it okay? In that, I think you are familiar with this idea. Using that concept, we can arrange this question, or we can solve this question. C plus B plus. So here, C displaces B, which means that the electron tendency, losing tendency of C, that is greater than B. Agreed? Yeah. Reducing tendency of C is greater than B. Right. Zinc displaces copper, means that zinc is more reducing agent, or more tendency to reduce than copper. Like, so here, D can't displace A, which means that zinc can't displace Mg2 plus, which means that Mg is a good one. So here D can't displace A means A is better than D, or A is good reducing agent. Like that, A can't displace C means C is good one than A. Like that, D can displace B plus means D is a little bit better than B. So you can arrange the most one with the greater reducing power. Which one have greater reducing power? C is better than B. C is better than A. And A is better than D. So a good reducing agent is C. Okay. Then B or A or D. Then we have A, B, D. Ready? We can simply compare B and D, which is more, D. And we can compare A and D, which is more, A. So it is clear that A will be the second, then D, then B. This will be the decreasing order of reducing power. Okay, it's a good question. Good question. Decreasing order of reducing power. So you can choose the choice as C, A, D, B. C, A, D, B. Your choice is 4. Okay? Your choice is 4. Ready. The next question. Next question is from redox reaction. Which element undergoes disproportionation in water? We already told you that your halogens, any halogens can undergo disproportionation in water except fluorine. Okay, turns to HX plus HOX. And the halogen may be chlorine, bromine or iodine, not fluorine. So here we can choose the chlorine. So choice is 1. The next is from your electrochemistry related with electrochemical series. So question number 15 is okay. It will be chlorine, not fluorine. Okay. What about the question number 17? Which substance serving as reducing agent in the following reaction? It is very easy, right? 14H plus Cr2 O7 2 minus gives, I'm sorry, plus 3Ni gives 7H2O 3Ni2 plus 2Cr3 plus. Okay, so which is serving as a reducing agent here? So we want to find reducing agent, or simply we can find the species which undergoes oxidation. This species undergoes oxidation, so this species should serve as a reducing agent. So it is nickel. The choice 4. Question number 18. Question number 18. The oxide which cannot act as a reducing agent. CO2, ClO2, NO2, SO2. Okay, so the oxide which cannot act as a reducing agent, which means the oxide which always oxidizing agent. Cannot reducing agent mean always oxidizing agent. Always oxidizing agent means that element should be in highest oxidation state, right? It is already discussed. If that element is in the highest oxidation state, then it can always act as a oxidizing agent. So oxidizing agent. So here carbon plus 4, chlorine plus 4, nitrogen plus 4, sulfur plus 4. The maximum of sulfur is plus 6, right? Maximum plus 6. So this is not maximum. Maximum of nitrogen is plus 5. So this is not maximum. Maximum of chlorine is plus 7. So this is not maximum. So these all can act as reducing agent also. But the maximum of carbon is plus 4, and here the carbon is in plus 4 also. So it can act as, it is in the highest oxidation state, so it can act as a oxidizing agent always, which means it never act as a reducing agent. So you can choose the choice as A. Okay. Moving to the next question. The oxidation state in oxidation state of Fe in Fe3O4. We know that Fe3O4, the oxidation state of Fe, we already discussed this in your exceptional oxidation state, F plus 8/3. Perfect. Question number 20. Oxidation states of A, B, C's are plus 2, plus 5, minus 2 respectively. Then the possible formula, it's very easy. Then the possible formula, it is very easy but may consumes more time. So the individual oxidation states are given. You're asked to design the formula of the compound. What about the A? A2BC twice. BC2 twice. And A2B2C4, right? Yes. Is it okay? A2BC2 twice. Oh, fine. So you substitute the values. Plus 2 into 2, that is plus 4. Plus 5 into 2, that is plus 10. Plus minus 2 into 4, that is minus 8. This won't be 0. So this is not the formula. Next, B. A3BC4 twice, which means A3B2C8. So if I'm substituting this all, plus 2 into 3, plus 6. Plus 5 into 2, plus 10. 8 into minus 2, minus 16. So this one will be 0. So this is the formula. Yeah. So no need of considering the other. Is it okay? Ready. Question number 21. Question number 21. SO3 2 minus. S2O4 2 minus. S2O6 2 minus. These all are given. The oxidation state of sulfur in the anions. So you want to arrange this in the increasing order of oxidation state. I think we know that this is plus 6. I'm sorry, plus 4. Because these offer minus 6. In order to get minus 2 outside, this should be plus 4. And this is S2O4. Yeah. This will minus 2. In order to get minus 2 outside, this one will be plus 6. Plus 6 means each sulfur will be plus 3. And this one will be minus 12. In order to get to minus 2 outside, this one will be plus 10. Plus 10 means each sulfur will be plus 5. So the least one is S2O4 2 minus. Then SO3 2 minus. Then S2O6 2 minus. This is the increasing order of oxidation state of sulfur in this compound. Here plus 3, here plus 4, here plus 5. Ready? So you can choose the choice as S2O4 2 minus, SO3 S2. The choice 1. Okay. Question number 22 is a question from your next equation, which means electrochemistry. We can discuss after covering the electrochemistry. So your discussion questions are over. Okay, we have one more topic pending. Okay, but the questions are not usually asked for NEET examination from that, but may ask for JEE examinations. Okay, that is titration. Okay,